Hello and welcome to Unit 9, Part 4. My name is Mr. Bell, and today we're going to use technology to find the line of best fit, which is also called linear regression, and we're going to make a graph to model the data set. On this slide it says to determine the line of best fit from the data below, find the correlation coefficient, which is the letter R, and explain its meaning. Remember us talking about data in the past, and the data is represented usually on a table. We have some X values, which are our domain, which are the hours that we studied. And then we have our range, which is the Y values, which represents the grades that were made based on how many hours of studying was done. And it's asking us to create a line of best fit from this. Now, I'm going to show you how to do this in the calculator because we're supposed to use technology and find the exact line of best fit. And also the calculator will help us determine the correlation coefficient, and I'll explain the meaning of that once we do that. But I'll have to change the format of the video, so we're going to hold off on that. We're going to take care of the second sort of question on this video, which just simply says to create a graph to represent the tables of values of the above. Be careful to scale your graph with the appropriate values. So let's start by drawing a coordinate plane. Okay, we have our x-axis and our y-axis. And now we're going to label the parts. And the tricky part is paying attention to scale. If you look at the range, or you look at the y values of our data set, they range anywhere, looks like, from 60 up to 92. So I've got to think of a scale or what value to give each step on my graph that fits all those points. Hopefully you notice that if I label my steps on the y-axis by ones, it'll take me a long time to get up to the number 92. So I'm going to go ahead and draw some steps here. There's 3, 4, 5, 6, 7, 8, 9, 10. And instead of labeling them by ones, I'm going to label them by tens. So this represents 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So my y-axis has been scaled by 10 in order so that I can actually plot these points on this graph. Now my x values range anywhere from 0 to 5. So these don't have to be done by 10. These can just be done by ones. Now that I have my domain and range labeled and scaled correctly for the particular data set that I have, let's go ahead and plot these points. First point says an x value or a domain of 3 and a y value of approximately 84. Now these won't be perfect, but I'll try to get close. Second one says 2 and 77, 5 and 92, 1 and 70, 0 and 60, which is the y-intercept, 4 and 90, and 3 and 75. So even though my graph and my scale is not perfect, we can get a general idea about the pattern or the trend. It certainly appears to be increasing as the y value seems to be increasing as the x values increases, which kind of makes sense. The more hours you study should result in a higher grade, but it doesn't always necessarily, and it's not a perfect line, a perfect rate of change every time. But by drawing this to scale and plotting the points, we're able to estimate the line of best fit by hand. Now we'll change format, and I'll show you how to do this in the calculator. Now that we've changed formats, I'm going to show you how to find the exact linear regression model or line of best fit using a calculator. So this is the same question that we graphed just a moment ago, except now I'm going to show you how to do it in the calculator and actually get the equation. Step 1 is to go to the menu, and in this particular calculator we're going to go to the stat function, which is number 2, and we have two columns here. We have an L1 column, we have an L1 column and an L2 column, or a list 1 and a list 2. Now here's what those columns represent, or what goes in those. The list 1 will be all of the X values of your data set, the domain, and the L2 will be the Y values of your data set, or the range. So I'm going to begin by inputting each member of the domain, and then after I put that first member, I have to hit the execute or enter blue button at the bottom to go to the next one, in which case I need to do 2, 5, 1, 0, 4, 3. So now that I've got the members of my domain entered, I need to use the navigation wheel to go to my list 2, which represents the range. And this is important. You need them to coordinate, meaning I need the 84 to be sure to be paired with the 3. So there's my 3. I'm going to make sure this one gets the 84. And as long as you're careful when inputting this, it's a mistake that you will not make. 70, 60, 90, 75. So now that I have my data set and each one matches like it's supposed to, I need to hit the calculate option, which is F2. I'm doing a linear regression model, so I'm going to hit regression. I'm going to click the X. Since we don't have this particular function, we're not dealing with a quadratic or cubic functions right now. We just need the X. And you have two different formats to put your answer in. I'm most familiar, and I think most of us are, with y equals mx plus b. And this is the closest this calculator will do for us. It gives us ax plus b, which is really the same format as our linear or slope-intercept form, except instead of using an m, they use an a. So I'm going to select that option. Here we go. So here's my equation, except a is 6.3. So y is equal to 6.3 x, and then my b, my y-intercept, is 62. I'm just going to leave that as 0.0. So plus 62.0. This that I've bubbled around is the linear regression, the line of best fit, the most precise measurement that I can do to represent this data. Remember, the graph that I did by hand was just a close representation. This is much more accurate. A y-intercept of 62, and then a slope or a rate of change of 6.3 for every x increase of x value that we input into this function. Now, we also talked about finding the correlation coefficient, which is the little letter r. And there's ours. Ours is 0.95. So our r is 0.95. And let me tell you what that means, okay? If your correlation coefficient is close to a positive 1, so the closer it is to a positive 1, means it is a strong positive correlation, which really means it's a set of data that forms a positive relationship as x increases, the y increases, and it's a very tight pattern, and I'll show you an example of that in just a second. The closer our r is to -1, it would be a strong negative correlation, okay, indicating a negative slope. I guess the closer it is to 0, you would say it is a weak relationship. So let's look at a couple of examples real quick before we bring this video to a close. So if I have a couple of different data sets here, this particular one has a pretty strong positive relationship. So the r would be a value very close to 1. This is an example of not so strong of a relationship. It's still positive. It's still generally going up. The y value is going up as the x value increases, but this might be an r value of 0.4. It's much closer to 0 than it is to 1, so this would be considered a weak positive. This particular example would be a very strong negative relationship, meaning the pattern is very tight. This might have our r value of negative 0.92. I'm just kind of making those up to give an estimate. And then, of course, this would be still a negative relationship, but much less strong. I would consider this a weak negative relationship. So maybe negative, I don't know, 0.3 sounds good. All right, thanks for watching. Hope this helps.